of block diagrams and bond graph models as they relate to the transformer element. On the screen right now you see there is a lever in there, which all of us know is a transformation between the forces and also the velocities of the endpoints of this lever. So the distance on one side is A, the distance to the other extreme is B. And let's see how we develop these equations, develop the bond graph model, and develop the block diagram. So here we go. We have this lever. It's very easy to see. If we write the let's use the proper term, the constitutive equations. How about that? Constitutive equations. Okay, so in here you have that, isn't it true that F1 multiplied by A should be equal to F sub 2 multiplied by B? Yeah, this is the so the moment on this side equals to the moment on this side. So therefore, it follows, and I will put it in, maybe with red ink, that you could write that F1 multiplied by this lever ratio is going to result in F sub 2. So you see, this is the input. This is the output. Yeah. You may say this is the cause, as we have done with the other elements. This is the effect. This equation can be represented by a block diagram and also by a bond graph model. But because it is a two-port element, we need to look at the other transformation that occurs. And that is the one between the velocities. So in here, isn't it true that the velocity 1 is omega times A? Yeah. Omega being the angular velocity. So omega is like this, yeah? Omega this way. So isn't it true that the velocity v1 is omega times A, and also that velocity 2 is omega times b? If you divide these two equations, you got that v sub 1 over v sub 2 is is A over B, because omega would be eliminated, like this. Yeah. So it follows that from this equation, you can write the other constitutive law, which it says that v sub 1 is equal to A over B times v sub 2. Now you see, this is the equation. This is the this is the relationship between the velocities. So you have two of these. The first one, you can say, I have a signal in here that is f sub 1, and I am going to multiply this by a gain of A divided by B, and out of this is F sub 2. But that would not be the complete picture, because we have this other transformation, and this is saying that the result B sub 1 is the result of multiplying B sub 1 is the level ratio multiplied by the input, which would be, in this case, B sub 2. This is B sub 1. So this is our block diagram. This block diagram represents this equation, like that, but also this equation, like this. Yeah? If we look at the bond graph model for this element, you're going to see that we write TF, and on this side, on each one of these sides, we have either the effort or the flow. So in this particular case, this is the effort, which would be, why don't we put it here, F1, and this is F sub 2 over here, like this. We need to fix it. Sorry. We need to do it right, all right? Do it nice and pretty. That way we understand each other really well. Okay. So what does it mean that F1 is the input? It means that the crossbar has to be like this, see? And the output is F sub 2. That is this equation. I mean, F sub 2 meaning the force. You could write this in generalized terms like TF yeah, this is A over V. This is F1 on TF multiplied by okay, so what I'm trying to tell you is that this is 1 and F sub 2 is that this bond graph is equivalent to these two equations. Yeah? So this is equivalent to these two equations. Now, if you write the equations a little differently, you remember that writing the equations a little differently produces another different setting. So why don't we do that? On the right, on the left-hand side, I'm gonna make a line over here so that we don't get confused. Oh, let's just do our fancy line over here so that we do it officially here. There we go. Oops, what did I just do? So the line, there you go, right here. Okay, very good. So now I need to show you how the equations would be written in a little different way. Let's take a look at this. How about if you say that F1 is equal to okay, this is saying that F1 is equal to A over B times F sub 2, right? See, yeah, B over A. Yes, it's B over A. And this other equation, you could be right that B sub 1 is B over A equals to B sub 2. Yeah, so whenever you have these equations, you're gonna have this. Whenever you're gonna have this equation, you will have the other block diagram that is going to be like this. See, in here, take a look. You're gonna have this, and you're gonna have it like this. This says this is the output that results from multiplication of this times this. But I need to correct that because that's what I'm saying is that you have it like this. See? This would be B over A. This is F2 and this is F1. This here would be B over A. This is B sub 1 and this would be B sub 2. The same thing in using the bond graph notation. I'll do it consistently here on this side. Here's the TF, like this. On this side, you see F2 would come in like this. And what comes out is F1. This is F1. The second equation has P sub 1 is the input. And so B sub 1 is the input like this. And this would be B sub 2. And the modulus in this would be B over A. So this is equivalent to these two equations. See, those two equations are equivalent. Okay, so that way we have the equivalency for the transformer element.